it laid out. This is the main thing in statistics. This is the main thing you would read about and want to know how to do. You know, in whatever job you are doing or end up doing, you might read a hypothesis test, a test that was done, and want to see what they did. All right. So I'm going to kind of whip through this quick and then slow down when we get to important things. So hypothesis test is a claim or statement about a property of a population. So it's a test of significance is another way of doing it. It's a procedure for testing whether a claim should be trusted or not. Here's an example. Let's get right to an example. The majority of consumers are not comfortable with drone deliveries. You guys know this is the new thing. I mean, it's going to be the future thing. They're already starting it. Right? What do they call it? Air. Amazon Air. You heard of that? Right? They're going to be delivering with drones. So starting out for companies, probably not for consumers right away. But business people can go online, say a factory needs something. Right now, they're building some important thing. They don't have it in their inventory. Amazon's setting up to where you can order it with them online, and they will fly it there with a drone within 30 minutes. 30-minute delivery from their plants. That's the future. They actually have a name for it, Amazon Air, they're calling it, and that's the plan. We're going to see drones flying through the air as Amazon, who's taking over the world, delivers, and I'm kind of happy with them, so I'm all for it. I'm sort of half joking, but anyway, so that is the plan, though. That is a likely future. So are you comfortable with that? Are you comfortable with drones flying around everywhere, delivering goods, delivering your stuff? Well, if they can get there in 30 minutes, I'm pretty much happy with however they got there myself. But that's pretty great, right? I mean, I think it's great 2 days. I have Amazon Prime. I love it. I went out to work on one of the cars. They had to tell me the air was low on my tires. So I brought an air compressor a couple of years ago, and I had one of those gauges, and I tried to check my tires, and the gauge is broken. Things always break. Sitting in the garage, haven't used it for a year. So I went on Amazon, found a new gauge, 2-day delivery. Boom! That was Wednesday. It was there by Friday. I'm like, this is great. I don't even need to go to a shop to have my tires checked. Anyway, I love Amazon. I'm a fan. So Amazon Air is going to deliver things in 30 minutes. I'm sure there's a high fee to have a drone. They're not going to bring me a tire gauge. There'd be a $1,000 tire gauge, I'm sure. But anyway, so 1,009 consumers were asked if they are comfortable with having drones deliver their purchases. And 54%, 545 of them responded with no. I don't know if that's how you feel. No, I'm not comfortable with the drone delivering my stuff. Using P to denote the proportion of consumers not comfortable with drone deliveries, the majority claim is equivalent to the claim. Okay, so a claim is being made. So this is like a court of law. The prosecution makes a claim. They say the majority. What does majority mean? More than half. More than half, right? The majority of consumers are not comfortable with drone deliveries. Is that true? Because Amazon wants to know, of course. That'd be if you were one of the board members at Amazon and you're developing this Amazon Air and you're pouring millions of dollars into getting this up and running, this would be an important question for you to know the truth about. Is that true? Do the majority, more than half, of consumers, are they not comfortable with drone deliveries? So how can we answer that claim? What do y'all think? Let's just be real about this. Statistics is real. So what do you think? If you're on the board and this study's brought to you, what do you think? Rudy, you're on the board now.
Based on that, yes, but that number of consumers that were asked, I think it's too low, considering how big Amazon is.
Yeah, they're big.
So, and considering, like, if there was, I don't know, 50,000 or 100,000, for instance, 100,000 Amazon Prime users,
yeah,
that's only, what, 10%?
Yeah, small amount.
So that's a small amount of people. I would want to know, like, 50,000 out of 100,000.
Right.
And then at least, to know how much.
Right.
For that.
Yeah, so you hear what Nurdine's saying, right? because they asked 1,009 consumers, and 545, 54%, just over half. That's more. That is a majority, right? That's more than half. 54% said, no, I'm not comfortable. I'm not comfortable with having my stuff delivered with drones. So on the one hand, Nurdine's saying, yeah, that's a majority, but then on the other hand, he's saying, yeah, but that's only 1,009 people. There's millions of people, probably, that use Amazon. Yeah, probably millions, right? They're taking over the world. So millions of people use Amazon. So that's only a small part of those people. So maybe we should not believe the results. What do y'all think about that?
I'll at least question it.
Do more surveys.
Got to have more people. So how many people do we need? What if there's 1 million Amazon customers?
At least half.
At least half? 500,000?
Because then at that point, you know that at least if half of the people you tested said, no, I do not, then that's, you get in more of the echelons of like 30%, 40% out of the entire group.
Right, so you have a big percentage, like half or something. Let me ask you this. What do they do when they poll for a national election? Same kind of thing, right? Right, when we're getting, when you start getting close to an election, about a year in it, they start early, they start polling about who the nation is going to vote for. And so, what do they do? What do you guys know about polling? When they poll, do they ask half the nation?
No, they pull from like a chunk from each like area.
They got to mix it up.
Stratified.
They got stratified. You guys remember all the stuff? They got to get certain men, women, rich, poor, country living, city living, etc. Different races, all the different genders, different ages, different income levels. They got to mix it up and make it a small United States, don't they? So that it's accurate, right? But is there any restriction on how many people they need to ask? In fact, you remember the Literary Digest poll? Remember we talked about it? It was our first week of class. We talked about that magazine that went out of business. And they thought, as long as we get a lot of numbers, it's all good. Remember, they asked 1/4 of the nation who they were going to vote for. And they got the stinking wrong answer really badly. And little Mr. George Gallup, he was nobody then, he's an icon in polling now. He is the name in polling now. But back then he was a nobody. George Gallup only surveyed, I think it was 6,000 people. And he got the truth that same year that the Literary Digest magazine got no truth at all. They surveyed 250, was it 50,000? And George Gallup only surveyed 6. And remember George Gallup's comment? If you stir the soup well, it only takes one little spoonful to know what the whole batch tastes like. Do you get the meaning of what he's saying? He's saying if you want to know the truth about a gigantic group, like what the whole nation's going to vote for, or what all Amazon customers feel, you actually don't need to have a giant bowl of soup out of that. As long as you stir it well, one little spoonful will tell you what the whole batch tastes like. You get the idea? We don't need a big group. Nerdy.
So for that, would you want to just do consumers in general without like Amazon Prime users or like people who have that?
Yeah, good question. Good question, huh? Yeah. Well, people that are at least potential consumers, huh? Because Amazon doesn't care if you're never going to use Amazon, I guess. But yeah, so that'd be a good question. Yeah, well, that's we probably won't get into that. But I mean, you're right. You would need to survey people that are at least potentially consumers. Yeah, that's true.
To have like a true.
Yeah, because that's the population they're interested in. They want to know, are people going to pay money to have this done? Otherwise, they don't want to spend millions of dollars developing it, right?
Yeah.
So everybody understand the issue. That was a good question. Does everybody understand the issue then? So there's certain now, if we only asked like 5 customers, and we said, hey, 3 out of 5 didn't like it. So Nuruddin has a point, but it has a limit, doesn't it? Do you feel that? If you only asked 5 customers, or consumers, and 3 out of 5 said they're not comfortable, you would see, I got a majority. 3 out of 5 are not comfortable, therefore a majority of all of our million customers are not comfortable. We better stop building this thing. Yeah, that wouldn't be enough. And do you know how we would find that out? I mean, just off the top of our head, we know 5 is not going to be enough. That would happen as you run the statistics. As you do the confidence interval, or we're going to do a hypothesis test, what would happen is the probability would be so large that you could get 3 out of 5 when that's not really the truth, that it would tell you that in the statistics. So you don't actually have to worry a lot about this number. It'll bear out in the probabilities that our calculators give us. It's all in there in the math calculations that the calculators do. So there is definitely truth to what Nuruddin is saying. You need enough people to be reasonable, but you don't need like half the population or anything like that. Does that make sense? So how would you decide? How would you decide whether this is true? Certainly 54% of these 1,009 are not comfortable. But is that what's going to be true of the whole population or not? Let's all right, so the big picture. We have the claim that the population proportion is more than 0.5. That's what we're claiming, right? You tracking with me? They're saying, now I want to make sure, let's go back. P is the true proportion of the whole group of well, I should say, instead of whole group, say of all Amazon consumers. Right? So there's a difference between, well, what's the 54%? That's what we call P hat. Do you know the difference between the hat and the regular P? Are you getting the hang of that? Whenever a hat, that little triangle thing, they call it P hat, that is the official name. Whenever that is on something, that means the sample proportion. Only from the 1,009 consumers. Right? So that's not the point. The 54% isn't, as you know, it isn't 54% of all Amazon consumers. It's 54% of these 1,009. It's just of our sample. It's just out of the 1,009 we asked, right? Whereas the regular P, that's what we want to try to figure out. That's the proportion of all Amazon consumers. All right, so that's our goal, is to find that out. So among 1,009 consumers, how many do we need to get a significantly high number who are not comfortable with drone delivery? So a result of 506. What if we? How many is significant? Because that's the question, right? We got to make sure this result really matters. We want less than a 5% chance of luck. You're totally right. But what I mean is, if we're going to say that more than half are not comfortable with drone delivery, what if we only got 506 out of the 1,000? That'd be one person over half. Would that make us believe? No, that would not be a very high amount. If we're only one person over half, we wouldn't have any confidence, would we, that for sure it's more than half? What if we got 1,006 people out of 1,009 that said they're not comfortable with drone delivery? Oh yeah, we'd be like, slam dunk, done. Of course, people aren't comfortable. But we got 545. It's kind of like maybe. We got to see. We're not sure. So let's go on. So we're going to use technology to do it. And there's the results from technology. I don't know if you can read that at all. But let me tell you the thing we're going to do it in our calculators in a minute. But let me just tell you the value we would care about. It's that one. Well, that's StatCrunch. Here's the TI. There's the TI. It's the p-value. And I'll show you how to do it. It's super easy. P-value. And the p-value is 0.00538, whatever. So 0.005. That's the number we're going to really care a lot about, is the p-value. That's the number for us tonight. Let me show you. Examining the 4 screens, they all include the p-value. Those are all different technologies, Minitab, StatDisk, TI-8384, StatCrunch. So anyway, the p-value, 0.005, like I said. So let's get to a conclusion about that. All right, so I guess we're going to start writing things. All right, so yeah, so let me give you the details. So what we're going to do in this section is we're going to write out a hypothesis test. There's something called the null hypothesis. You write H sub 0, and then next we're going to go to the alternative hypothesis, which is H1 or HA. In this book, we'll use H1. So this one's called the null hypothesis, and this one's called the alternative hypothesis. So we have the null hypothesis and the alternative hypothesis. So the null hypothesis always has an equals. That's the part you want to remember. The null hypothesis always has the equals, and it is the assumption. It is the assumption. It's what you assume is true. Okay, so in the question we're looking at, what is the claim being made in the problem we're working on right now? What are they claiming? Did you notice? Let's go back to the claim. Oh, it's right at the top. Majority of consumers are not comfortable with drone deliveries. Majority. So what does majority mean? More than half. So the claim is that P, the true percentage that don't like drone delivery, aren't comfortable, is more than 0.5. That's what's being claimed, right? That's what's being claimed. Now, so that is not going to be my H0, is it? Why not? Because not equal, exactly. It's not equal. So that has to go here. See how I'm coming up with that? We'll do a bunch of these. You'll get the hang of this. But let me just, for right now, say you just write down the claim. What you do, whenever you read something that's being stated, you write down the claim, P greater than 0.5, majority, more than half, more greater than 0.5. And how you know whether it goes on HO or H1 is only equals can go on HO. So if the claim was equal, some of them will be. But this one's not, so it's got to be the H1. Well, then what's the HO? It's going to be P equals 0.5 because it's always equals. HO is always equals. And so what we're saying when we say that is we're saying we're assuming the percentage is actually equal to 0.5. Exactly half are not comfortable. But the claim is more than 0.5, more than half, a majority, are not comfortable. So that's what we're going to try to determine with evidence. Which one is it? Is exactly half or more than half not comfortable with drone delivery?
Why do we... Never mind, I'll let you continue.
Okay. All right. So there. I'm not gonna read through all that. I'll leave that. It's on your notes. I put all these on the website. If you ever want to look back and track through, I'll be leading you through it. That too. I'm not going to talk about that, but I just thought I wanted to leave it on the notes for you in case you ever want to keep it and refer back to something. So I'm going to move ahead. So step 1, identify the claim being tested. We did that. The claim was, again, P is greater than 0.5. Step 2, give the symbolic form that must. Oh yeah, what's the opposite? So if the claim is false, the opposite would be less than or equal to 0.5, right? That's the opposite of greater. If it's not greater, it's less than or equal to. And then figure out which one is the null. The null has to be the equals. We did that. So now notice this has less than or equals. Because it has the equals, it had to be the null. We're not going to put less than or equal. We have to put equals for the null. I'll explain more about this later as we go. And that's the null and the alternative, as we talked about. All right, so let's go through. They're going to go through these same steps. Identify the claim. There it is. P is greater than 0.5. Okay. If it's false, if the claim is false, the opposite would be less than or equal to 0.5. That's the opposite of greater than 0.5. Right? If the greater than 0.5 claim is false, if it is false, then P must be less than or equal to 0.5. And then, how do you identify H1? How do you define HO? There it is. HO is equal. H1 is greater, as we said. It's because this does not contain equality. So the equality has to go there. Significance level. Well, yeah, we just pick whatever level we want. That's like how significant. Usually it's 0.05. Sometimes they do 0.01 or 0.10. 0.05 is the most common, like we talked about. So p-value. The p-value is the probability of getting a value of the test statistic that is at least extreme as the statistic obtained. I'm struggling with this. From the sample data, assuming that the null hypothesis is true. That's some fancy verbiage, isn't it? Yeah. Here, I have a saying for p-value. P-value is the probability that the results are just luck. The probability the results are just luck. Now, you're not going to see that in any book, but that's basically what they're saying. That's what all that fancy talk is saying. I'll bring that up as we see actual examples. But that's what the p-value is, because there's always the chance of luck, right? You could have talked to 1,006 people that just all luckily happened to be kind of negative about drones. That's possible. How likely is that, though? That's what we want to measure. That's what the p-value gives us statistically. All right, let's get into the thing. P-value 0.005, blah, blah, blah. What's that mean? Don't confuse p-value with parameter. Yeah, I think we're okay. Remember I told you this is the sample, this is the population. P-value is the probability. All right, step 7, decision criterion of the p-value method. If the p-value is less than or equal to alpha, alpha being the significance level, the author has this... The author's Triola. I don't know if you know who wrote this book. Mario Triola. He's a famous statistics author. He's been around for years. Anyway, his nice little saying, I thought that was kind of helpful. I never heard it before this class. If the P is low, the null must go. I think I'm going to use that because he's right. And you'll see when we start doing actual problems how that works out. So it's a good little memory device. If the P is low, the null must go. So I'll explain that as we look at an actual example. So restate the decision, blah, blah, blah. So let's do it. Let me finish up. So what was the p-value when we looked at the output from data? It was 0.005. What was the significance level? It was 0.05. This is lower than this, right? 0.005 is lower than 0.05, isn't it? That's a very low p. That's good. That means you got strong evidence. That's like, in the courtroom, they have like DNA evidence and strong evidence. So, remember what the H0 was in the H1. H0 was P equals 0.5. H1 was P greater than 0.5. Which one do we believe? If the P is low, lower than the significance level, it is. If the P is low, the null must go. So forget the null. This is our conclusion. There is strong evidence that the proportion of people among all Amazon customers is greater than 0.5. That is strong evidence, actually, is what we're saying. Statistically speaking, that data they came up with is strong evidence that really, truly, greater than 50% of all the Amazon customers are a little uncomfortable with drone deliveries. That's what our conclusion would be. So let's see if they're doing it. There is sufficient evidence to support the claim that the majority of consumers are uncomfortable with drone deliveries. There is sufficient evidence to support the claim. All right. So so final conclusion, that's what we just did. Oh, and then there's 4 possible things. Don't worry about this. I just want this in your notes, but you don't need to write it down. But it'll be on I put it on the Canvas. It's on the course lecture notes under Canvas if you ever need it. I'll be explaining as we look at examples about all this. I'll explain exactly what this is, and I'll come back to it. Restate the final decision. It's all about accepting or failing to reject. I'll explain that. Oh, and then the errors. Okay. So here's your actual homework. So I'm doing actual homework now. Here's question number 1. So and I'll go back to the notes, and clarify where we need that. Bottle contains a label stating that it contains pills with 500 milligrams of vitamin C. And another bottle contains a label stating that it contains pills with 325 milligrams of aspirin. When testing claims about the mean contents of the pills, which would have more serious implications? We're talking about right now the seriousness of different claims, because not all claims are the same seriousness. Which would have more serious implications? Rejection of the vitamin C claim or rejection of the aspirin claim? So which one would be more serious? Yeah, obviously, aspirin is much more serious than vitamin C. So that's the first thing they're just pointing out. Rejection of the claim about the aspirin would be more serious, right? If that aspirin doesn't really have in it what they're saying, that's more serious than the vitamin C thing. Is more serious because the wrong, again, aspirin dosage could cause more serious adverse reactions than a wrong vitamin C dosage. It would be wise to use a significance of, smaller means tighter data. Yeah, that's stronger evidence. Smaller's right there. So let's start getting used to that verbiage. Significance level is the test level. So, if you have a significance level of 0.05, that's smaller than like 10. Now, what does that even mean? That's the chance of luck. Do you know what I mean? Like, think about the court of law, right? Think about a court of law. Couldn't it, because, what do they say in a court of law? They say, jury, you must come back with a verdict beyond a reasonable doubt. Why do they say that? Because you could always doubt. You know what I mean? Maybe an alien came down and took the body of the murderer and did the murder and then jetted out of there, and it's not really the murderer's fault. Yeah, maybe. Yeah, man. My brother's cousin. There's always, somebody can always make up some crazy, whacked out doubt, right? It's always possible to come up with some crazy, wacky doubt. But is it reasonable? Is there a good probability of that happening? So that's what we're talking about. The lower this goes, this is the chance of luck again. That's the way I'm going to put it. The chance of luck. So if you were thinking about the aspirin bottle, and you're about to take aspirin, and they said, "Hey, we're pretty sure that there's 325 milligrams of aspirin, but we might be wrong. We did some testing, and based on how many we tested and everything, how many bottles we sampled to make sure the manufacturing process was accurate, there is a 10% chance that we just got lucky, and the bottles we looked at were good, but really, it's not actually right. Well, or we did more testing, and there's only a 5% chance of luck. You would rather the 5% chance. You tracking with me? A lower chance of luck means the results are more sure. Just like in a court of law. If they have strong evidence with less chance of luck, then you believe the results more strongly. You feel more comfortable with the verdict, right? Does that make sense? All right. The Erickson method is one of several methods claimed to increase the likelihood of a baby girl. In a clinical trial, results could be analyzed with a formal hypothesis test with the alternative hypothesis p greater than 0.5, which corresponds to the claim that the method increases the likelihood of having a girl so that the proportion is greater than 0.5. If you have an interest in establishing the success of the method, which of the following p-values would you prefer? So if you're doing this claim, if you're one of the people working on this thing and you really want the method to be proved true, and the alternative hypothesis is greater than 0.5, that's what you want, right? You want to prove that this method produces more than half the time girls. That's what the method's supposed to do, right? Make it more than likely that more than half the time, girls are born instead of boys. Who wants those stinky little boys anyway? They want girls, right? I'm just joking. It seems like it's always girls with this author, huh? Anyway, so do they make tests where the higher probability of boys? I don't know. Anyway, so which p-value result would you want? If you want this to be proven true, which of these p-values do you want? Let me give you this phrase. If, remember that phrase that the author came up with. If the p is low, the null must go. Now, do you want the null to go or not go? What's the null? The null is the other one, the h sub 0. That's called null. I don't know if you know where they come with that. That little sub 0, they call that null. In the math science world, whenever they put a little sub 0 next to something, they call that the null whatever. So that's the null h, the null hypothesis. So the null hypothesis is the other option, like the prosecuting attorney or the defense attorney, whatever, the other side. So do you want the null to go? You do. You do, because you want this to be true. So you want the other side to go. You want the null to go. So what p do you need? Yeah, the low one. You want the lowest possible. You want the 0001, or however many O's that is. 001 is preferred because it corresponds, most strongly supports the alternative hypothesis, right? Because the null goes, and it supports the alternative hypothesis. And they told us that up here. They said alternative hypothesis greater than 0.5, that's what you want. And that the method is effective. That more than half the time a girl is born using that method. We good? Does that make sense? I know you're just getting used to all this. It's a whole new world. It really is. It's a whole new world of words, and we'll go slow and get used to it. We're going to be doing these for the rest of the course in various forms. Hypothesis. This is the main attraction of statistics. So you'll get much more comfortable with this. No, this is just the tip of the iceberg. And really, we'll be using these same words over and over again. You'll get super comfortable with them. We'll do them again and again. Okay, so here's the claim. Most adults would erase all of their personal information online if they could. Is that how you feel? Yeah. Erase all your personal information? A software firm survey of 519 randomly selected adults showed that 62% of them would erase all of their personal information online if they could. Complete parts A and B below. Okay. So express the original claim in symbolic form. Let the parameter represent the adults who would erase all their personal information. All right. So here we go. So those problems 1 and 2 were kind of weird questions asking us about weird stuff. Here's a normal, and all the rest are going to be like this one. So here we go. If you've been dialed out, dial back in. Here it is. Normal hypothesis question. Here we go. So first thing they want to do, this is the first thing you do on a hypothesis test question, is say, well, what do they say? What's the claim? A software firm survey. Wait, I don't know. What is the claim? Oh, claim right there. Whoops. I just blew it. Where is it? Right there. Claim right there. Most adults would erase the stuff. Most. What does most mean?
Majority.
Yeah, majority. Same thing as majority. More than half, huh? More than half. So what are they saying? P is what? Greater than 0.5 again, huh? 0.5 for half. It's the same thing as the last one, right? So P is greater. Do they even have me to... They don't even want the 0.5 anywhere. All right, they just want the P and the greater.
They want the 0.5 just on the bottom of the square right.
Oh, is that where they want it?
Yeah.
Oh, down here.
No.
It's P...
No, right
Up
next
there
to
on
it?
top.
To the right of it?
A little downshift.
No. How I know is because this is all number 2.
This is in decimal, something integer or decimal,
Oh, it does, huh?
not round.
Decimal. So we're
Oh, you're right. Yeah, I guess I just put the numbers for those blanks. Oh, you're right. So I don't know. P is greater than 0.5. Yes, you're right. Thank you. P is greater than 0.5. All right, identify the null and alternative. Yeah, okay, so It's going to be P in both cases again. So now, if P is greater than 0.5 is the claim. So this is the claim. This is what they're saying. More than half of adults would erase their info online if they could. So how do we write the HO and the H1? The HO is the null hypothesis. The H1 is the alternative, right? The null, sub-zero always means null. Null and alternative. How do we write those?
Is equal.
Yeah, what does the null have to be? Always. That one's equal. You getting the hang of that? We'll do 1,000,000 of those in the next 2 months. Yeah, and it's going to be 0.5, of course, and this is going to be 0.5, and then this one's going to be greater. You must have a different question. What do the words say at the top, Eddie, on yours?
Mine says claim most adults would not erase all of their personal information.
Yeah, would not. This one says most would erase.
Yeah, that's equal not.
So if most would not,
The other way around?
then less than half would, huh? Does that make sense? Yeah, so if they give you would not, if they give you, more than most would not, then you're claiming the proportion that would is less than half. Less than half would.
Yeah,
Does that make sense?
yeah. Yeah, no, it does not, because I'm looking at both of them, so it kind of makes sense on
Yeah,
one or the other.
yeah.
What you're saying.
And that's all they want for us in that question. We're just practicing setting these things up.
Okay.
Is that good? So the main thing to remember, the equals is always the null. He's always the equals. So we'll try that one. Number 4, see if you can set that up. Let me let you read. Can you read the words? The mean pulse rate in beats per minute of adult males is equal to 69.3 beats per minute. For a random sample, 167 adult males, the mean pulse rate is set. So there's a claim. See how there's always a claim, and then there's data which supports or doesn't support the claim. See?
So HO is the P and then H1 is the null. H1's null.
No, HO is null.
HO is
Yeah, HO is the null. That little zero thing means null. I don't even know why they call it null or what null stands for.
H1 is just H1.
Is the alternative.
No, like none, right?
H1 is the alternative.
Is that what you're saying? No, like none, and then 0 is none. That would be it?
Yeah, maybe. You're saying that's where it comes from?
Yeah.
Yeah, that could be. Null. Yeah, null means none, huh? Yeah, I guess so. Yeah. I guess it's as simple as that, huh? Yeah, null means none.
The little 0.
It's
like in tennis.
It means it doesn't.
15 mil.
I think they say love, so that'd be a little different.
Like your
Yeah.
marriage been unhold.
Yeah. Boy, you guys are rolling with this now. Yeah. Yeah, it all makes sense. In math, they say the null set. I don't know if you've heard of that before. It's an empty set. So it means nothing. Yeah, so the null just means the 0. Nothing. Okay, anyway. But start with the claim. What's the claim? What is being claimed? Start with that. They want you to write the claim right here. So first write the claim, and then, let me give you a second, then write the H. Okay, so what's the claim? What are they saying? The claim is the mean. Now, what is mean? Is mean a P or a sigma or a mu? I don't know. Are you familiar with that? It's the mu. That little mu symbol, that's a Greek M. I know it doesn't look much like an M. It looks like a U. It's mu, and the M is for mean. It's a Greek M. They use Greek symbols just to make it more confusing, I think. I still remember when can I tell? And the teacher, it was like the first week of class, I think. He wrote, Mr. Grimes, he wrote on the board, alpha squared, Mr. Grimes, alpha squared plus beta squared. Same thing in Greek symbols, right? This is gamma. It's another Greek symbol. Alpha squared plus beta squared is again. It's the same thing. It's just a squared plus b squared, c squared, except it's with Greek symbols instead of English symbols. That confused me not just all semester. Remember high school? That was all year. All year. I was like, what is that? Because those Greek symbols, they just completely threw me off. And I was such a young punk that I was scared to go up and say, hey, Mr. Grimes, what are those symbols? I mean, what was my problem? All year. What are those? I don't know. What are those? Yeah. It's crazy to look back when you're, I don't know, for me anyway, when I was a kid, I was such a punk. I mean, just go ask them. My goodness, grow up. All right. Anyway, all year, I never figured it out. It was just Greek symbols. So anyway, that's all they're doing. They're just using Greek symbols. So the little mu thing, that's, I'll write mu, like a cow almost, mu, and it's mean. It's for mean. All right, so mu, what are they saying? The pulse rate is what? Equal to 69.3. That's the claim. That's what they're saying, right? The claim is the mean.
The mu, though, for the mu, I just set for that.
Oh, they'll just give you the options. See the three options down here? It's either going to be P.
It's a mean, not probability.
Oh, yeah, because it says mean
Oh.
and not probability. Exactly. Thank you. You should be teaching the class. Exactly.
Yeah.
Yeah, mean. There it is. So mean instead of proportion.
Attractive.
Yeah, mean instead of proportion. In other words, it's not a percentage. It's not 70% of the people or 80% of the people. It's beats per minute, 69.3. So yeah, so mu equals 69.3. So now, how do we write the HO, the null hypothesis? So it's going to be mu again. We're going to use mu all the way through. This one's always equal, isn't it? Remember, the null is always equal. The null is always equal. So that's going to continue to be 69.3. And then the other one, mu. Now, what's the opposite of equals? Not equals. Isn't the opposite of equals not? It could be greater or less. It's not equals. Does that make sense? The alternative has to be the opposite. Does that make sense? Now, you might wonder, like, well, why did we do greater and less before? Well, last time, here, I'll flash back real quick. Last time, the claim was greater. So that had to be the alternative, and the null has to be equal. Remember, the null has to be equal. He has no choice. He has to be equal. The claim was greater, so that couldn't have been the null. That had to be the alternative. Everybody see that? Because the null has to be equals.
What was
Leonardo.
the opposite then?
What's that?
For the,
So these, on number 3 here, these are not truly the opposite, are they? Well, they're not completely the opposite. How about that? Yeah, you're right. These are not, equal is not completely the opposite of greater. What would be the opposite would be less than or equal. But we're never going to make the null anything but equals. So that's why we don't do truly the opposite. Does that make sense? It's a good question.
I noticed that the top usually matches the alternative, like the claim.
It won't always.
Oh, always.
In fact, it doesn't on number 4, does it? Take a look. The claim is equals, and where'd that end up going? On the null this time.
Oh.
So that can move. So that's not what you can count on. Well, what can you count on? The null is always the equals. That's what you want to set in stone. That's what you can count on. The null is always equal. So if their claim is equals, then that's where the null goes. If their claim is not equals, then it'll go in the alternative. Let me say that again.
Yeah, say again.
So the null is always the equals, without exception. Always the equals. So if their claim also happens to be equals, then their claim will be the null. But if their claim, what they're saying in words, is something other than equals, then their claim will go down here as the alternative. Because the null has to be the equals. Does that make sense?
It's good.
All right, let's keep.
I think with time.
Yeah, we'll do these for the next 2 months. So now we're kind of jumping into a little different kind of questions. Claim. Most adults would not erase all of their personal information online if they could. So now there's claiming the opposite. A software firm, 572, showed that 49.3% of them would erase all of their personal information online if they could. Make a subjective estimate to decide whether the results are significantly low or significantly high, then state a conclusion about the original claim. So they're just seeing if we're having a feel for what's happening here. So let's think about what's happening. Here's the claim. The claim is most adults would not erase their information if they could. So that's the claim. Now here's the study being done to support or reject the claim. 573 randomly selected adults were surveyed. 49.3% of them would erase. So let me write that down. The claim is most would not erase. The data, the study done, the study data showed that 49.3% would erase. All right, what do you think? Let's just talk real life here for a minute. Does the data support the evidence? A little, a lot, not at all, opposite? What do you think? So the claim is that most, what does most mean? More than 50% would not erase their data. The study data, when they went out and checked with people, showed that 49.3% would erase. Now, is that more than half?
No.
So less than half would erase. So what does that mean about how many would not? And yeah, whoever's left. And is what is left more than half or less than half? More than half. So that means the study data means that more than 0.5 would not erase. You agree? Does that make sense? If less than half would erase, then more than half would not erase. Does that support the claim? What was being claimed? Most, more than half, would not erase. Did the study data support that?
Yes.
Yes, more than half would not erase. So yes, the study data supports the claim. Now, does it support it strongly?
No.
Or like barely? Barely, exactly. If it was like 80% or something, of the people surveyed would not erase, then we go strong support. That's like barely supporting. It's just barely over half, isn't it? Because almost exactly half would erase. It's really close. So yes, it supports it, but very weakly. So let's see if we can answer their questions. The results are not significantly. Well, it's kind of a weird question, honestly. What do they mean? High. But when they say high, do they mean this is high or low, or do they mean? What do they mean? I'm not really sure, honestly. So I know this is not sufficient evidence to support the claim. The results are not significantly.
The 50.7.
Good question, exactly like this in the test. Whenever they say the significance of results, they always mean that chance of probability thing I was talking about. In other words, it's not low enough. And I know you're looking here going, they don't mean that percentage exactly. They're not looking at that exact percentage. They just mean there's too much of a chance of luck. The results are not significantly low enough. They mean chance of luck is not low enough. That's what they mean. Is that making any sense at all? I know that's confusing. So it's like what if I said, hey, I think my statistics class would like an exam every week instead of just 4 exams this semester. Your name's like, I don't need a survey, Mr. Herron. I know the answer. And what if I said, you know what? I'm just going to ask the front row. Right? And I asked just the front row. And And Mai and Sean were like, yeah, that's how I feel. Right? And so 2 out of 3 were like, yeah, I want to test every week. And I said, hey, I made a claim. I think y'all would prefer a test every week. I did a little survey, 2 out of 3. Said, yes, I think the majority of all you must want to test every week. Well, could it be that I just got a lucky survey? That Mai and Sean just love tests. And it was just a lucky pick, but that most people don't feel that way. Yeah, the chance of luck is too high. If you only ask 3 people, anything can happen. That's what we're talking about here. This is too close to 50%. Right? It just could have got lucky that it barely was more than half. Don't pray. It's so close. So my point is the results are not significantly low enough. They mean the chance of luck. The chance of luck. Whereas if I asked half the class, right, then there'd be a much less chance of luck. You get the idea, right? That's always what they mean. Significantly low chance of luck. They're not low enough. The chance of luck is not low enough. All right, I know that's... So make a decision about... Okay, let's try one. Make a decision about the given claim. Use only the rare event rule and make subjective estimates to determine whether events are likely. For example, if the claim that a coin favors heads and sample results consist of 11 heads and 20 flips, that's not sufficient evidence to support the claim. I'll explain that. Let's go on to the claim. Here we go. Claim. The mean pulse rate, in beats per minute, of students in a large stats class is greater than 60. That's the claim. A simple random sample of students has a mean pulse rate of 60.7. So what if a stats teacher claims, hey, I think mean means average, right? Mean is average. I think the average pulse rate is greater than 60 in my stats class. And then he or she surveys, grabs a bunch of students at random, does a random survey, and finds for the survey an average of 60.7. So what do you think? Does that support the claim or not? What was being claimed? What did the teacher claim?
Average.
Yeah, they claimed that the average pulse rate would be greater than 60. That's the claim, right? The average mu greater than 60. That was the claim. What did the data, the study data, the sample data, came out 60.7. Is that greater? Is it greater by a lot or greater by a little?
A little.
Just barely. Barely. So would we say that supports the claim? Really weakly. Really weakly. That kind of evidence would never put somebody behind bars, and it shouldn't. That's weak evidence. That's not beyond a reasonable doubt. That's what these hypotheses are all about. Having strong data that's beyond a reasonable doubt so you can really believe a claim. That's not strong data, is it? You see what I mean? That is not strong data. That's like barely. That's like, hey, the murder person is under trial and we think he had bad feelings towards this other person. That's all we got. We got no witnesses. We got no other evidence. We just heard one time he has bad feelings. Well, that's not strong evidence, and nobody should be put away based on that kind of evidence. That's kind of what this is like, right? This is very weak evidence. So the sample is not unusual if the claim is true. Oh, wait, this is weird. These are weird words. The sample is unusual if the claim is true. Okay. Suppose the claim is true. What if the claim is true? If it's true, if this is true, so they're saying it weird again. They're just trying to get at your understanding. If the claim is true, what does that mean? Well, the average is really greater than 60. The average pulse rate is really, in the class, is really greater than 60. Right? If the claim is true, then the average is really greater than 60. If it really is greater than 60, and you went around and measured the average, would 60.7 be surprising to you? No. You'd go, yeah, I thought it was greater than 60. It came out a little greater than 60. It wouldn't be surprising. It wouldn't convince you of anything, but it wouldn't be surprising. So the sample is not unusual if the claim is true. That's true. It's not unusual if the claim is true. The sample is not unusual if the claim is false. Therefore, there is not sufficient evidence to support the claim. Yeah, that's right. Is that making sense? I know this is probably confusing getting used to this. These results are simply not unusual, period. Do you see what I mean? That came out really close to 60. Those results are not surprising in either direction. If the claim is true and the average is really more than 60, those are not surprising results. If the claim is really false and the average is really less than 60, that's still not that surprising. It barely went over 60. There's not sufficient evidence. Wait a minute, does D say the same thing? The sample is not unusual if the claim is true. The sample is not unusual. Therefore, there is sufficient evidence. No. There's not. One little word. There's not sufficient evidence to support the claim. There's not enough evidence. This is not strong evidence. There's not sufficient evidence to support the claim. Does that make sense? That's not beyond a reasonable doubt. All right. I feel like,
We just got to doing like a complicated chapter, and now we're even more. Yeah.
I know, I hear you.
Does it get worse from
Can you
this?
use a calculator for this stuff?
Well, yeah, no, it's just all the words, huh? In the next section, we totally will. Yeah, when we start actually doing them, yeah, that'll be actually better. We'll be using the calculator. That's Wednesday night. Yeah, this is all just this section is all the verbiage. It's all the words and what all the words mean and imply, which is hard to do when you're not used to these things. This section will probably make more sense after the next two sections, because after another week from now, because you will have done more and more of these. Looking back when you study for the exam, probably make more sense. We'll see. All right, so assume the significance level 0.05, use the information. Original claims. More than 52% of adults would erase all their personal information if they could. The hypothesis test results p-value 0.2575. Okay. So, state a conclusion about the null hypothesis. Okay, let's get down to it. So, it's all about the p-value. So, let me write that out for you. The p-value is 0.2575. So, is that remember, you want the p-value to be really low. That's the chance of luck. Yeah, that's too high. You want that, it should be, it should be less than 0.05. Remember how we always use 0.05 as, if something has less than a 5% chance of luck, that's strong evidence. Right? You with me? If you're ever on a jury and there's less than a 5% chance of luck, then that's strong evidence. That's generally considered strong evidence. So that did not come out low. It should be less than 0.05. It is not. It is not less than 0.05. It's like 25%. There's like a 25% chance that these results are just luck. Like me asking Sean and Mai, and they want to test every week. They're just different than the rest of you. They just love tests. It's just a lucky pick, right? So that's what we're talking about. Luck can happen when you survey things, and this is just too big of a chance of luck. So, now remember the saying, remember the author's saying, what does he say? If the P is low, the null must go. So was the P low? Not a low P, right? It's supposed to be under 0.05. That's what we mean by low. We mean under 0.05. This P is not low. So the null will not go. away. So we keep the null. Did you follow that logic? Did you see how I went through that? If the null is if the p is low, the null must go. But the p was not low, so the null will not go away. We'll keep the null. We're keeping the null. We're not rejecting the null. We're keeping the null. So what does that mean? Fail to reject the null. Fail to. It's one of those two. It's either A or C. I got to read the rest of the words. So far, so good. It's not. We're not going to reject the null. We're keeping the null. We're failing to reject the null. You tracking with me? Right? The null's not low. He's not going to go. We're going to keep him. We're going to fail to reject him. Why? Because the p-value is greater? No. I mean, yeah. It is. It's too great. It's too big. The p-value is not less than 0.05. The alpha, that's the alpha level, 0.05. The p is greater. It's too big. Right? That's it. That's our answer. The p-value is greater than alpha. Alpha is the 0.05. That's the significance level. You tracking with me? That one okay? Eddie?
On the homework, it's going to be D because the p-value is less than or equal to.
Well, if it was, but it's not. So this, my p-value is 0.25 that they're giving me. See right here, 0.25?
Wait, never mind.
Yours is different.
Sorry.
All right, let's go on to part B. So in part B now, without using technical terms, state a final conclusion. Which is correct. So what does that mean then? This is the part that really matters. Because this is where you will use statistics. If you do use it, you'll use it in this way. What does this mean, real life? So what is the null and what is the H1? Let's be clear on that first off. What is the null and what is the H1? What's the null? What's the claim? Original claim, more than 52% of adults would erase.
So p greater than 52?
Greater than 0.52. That's the claim. Yeah, beautiful. That's the claim. We good so far? Now, does that go? Everybody good, right? I'm just simply reading those words. The original claim, more than 0.52. P greater than 0.52. That's the claim. Now, how do you know if that goes in the null, HO, or the alternative, H1?
Must stay. The null must stay.
Well, no, we'll get to that. But remember, what is the HO always?
Equal.
Equals. Is this equals?
No.
So he doesn't go in the null, does he?
No.
You tracking with me? Remember that fact? I know we have a lot of facts coming in, and it's all brand new. So one more time. The HO is always the equals case. Always equals. Let me write that again for you. So the HO is always the equals. Always. Every problem without exception. HO will always be the equals. So does this say equals? No. So he's not the HO. So that means he goes down here. And then what's the HO? It's equal. Equal to 0.52. Is that making sense? See how that works? So again, let's rehearse it again. So whatever they say, their claim, write that down exactly what they're saying, more than 0.52. And then if it has equals, it goes into HO. If it doesn't have equals, it goes into H1. And the HO will be the equals. HO is always equals. Always. All right. So what did we decide to do? Did we decide to reject the null or keep the null? Keep the null, right? We're keeping the null because the P was not low, right? The P was too high, so the null's not going to go. We're keeping those, so we're keeping this conclusion, aren't we? That's what we're keeping. So how do we say that? What does that mean then? Was there strong evidence or not strong? Here's a third word which you need to know. And I haven't really made clear yet. So yeah, in fact, let me summarize some things. So we got enough to make a nice little summary now. So HO always equals, and that's one thing to keep straight. HO is always the equals, and then if the P is low, less than 0.05, then the null must go. Reject the null. Okay, there's that fact. And then there's a third fact that I want to make clear for you. The HO and the H1. In a court of law, in a criminal case, how does it work? If somebody is being accused of something, murder, do we just come in and just say, hey, just start giving evidence one way or the other? If there's more evidence of innocence, we'll vote innocent. If there's more evidence of guilt, we'll vote guilt. Kind of like a 50-50 deal. Whichever side has a little more evidence, we're going that way. No. There's an assumption. It's in our very fabric of our society. Assumed what? You'd be a rough judge.
Yeah.
I'm assuming you're guilty unless somebody tells me other. You just look guilty, buddy.
It does.
You know, it's funny. I was on maybe shows otherwise, right? Well, it's the same thing here. One of these is assumed to be true unless strong evidence indicates otherwise. And you need to know that. That's going to be really important for how these things bear out. So, right? So if they just have willy-nilly evidence, then they don't convict somebody of murder, and they should not. Right? And maybe the person did it. Now, I can tell you about my rape trial that I was in, more than a year over. Do I think that person maybe did that? Yeah, I think probably. But the evidence wasn't strong. Honestly, the gal was drunk, the guy was drunk, everybody was drunk, and nobody had any real strong evidence. Yeah, there was so much alcohol, and she was drunk, and they put her on the stand. She said, I don't know, I don't remember, I don't know, I don't remember. And I went, I feel bad for you, but you got it. I can't put that guy away unless you can really say. Anyway, so we released him. I was actually the last one to release him. I was a little bit more like, and my jury member's like, there's just not strong enough evidence. And they convinced me. I was like, yeah. I was the holdout. I was causing the problem. In the end, I was like, yeah, there just isn't. There just wasn't strong enough. Do I really think he probably did it? Probably. But there was just too much. There was just too much uncertainty. So that's how it is in the court of law. That's how it is here. Right? You assume innocence. We assume that young man was innocent unless evidence was strong the other way, and it just wasn't strong enough, wasn't clear enough. I think that was right what we did. And that's how this goes too. One of these two is assumed true, and you stick with it unless strong evidence moves you otherwise. Which one is assumed to be true? The null. You assume that HO is true unless strong evidence moves you to H1. So let me just leave it that way. So basically, if evidence, so here's what we're going to say. Here's my point in all that. That matters in how you reach a conclusion. Like would I ever say, after that rape trial I was on, would I ever say, there is strong evidence that young man didn't do that? No. There wasn't strong evidence. But there wasn't strong evidence he did. So we released him. Right? That's very different. Right? That's very different. There was not strong evidence of his innocence? No. But there wasn't strong enough evidence of his guilt. So that's how this is, and they're gonna test you, and they want you to word it the right way, and that really matters. So basically, whenever you're concluding H0, you're gonna say, how do I do this? You're gonna say, let me say it this way. Whenever you're going with H1, you had strong evidence to reject the null hypothesis. Reject the HO. So whenever you're going with H1, like whenever you come down with a guilty verdict in a criminal trial, there better have been strong evidence there better have been strong evidence. That's how it is with H1. H1 requires strong evidence. So, and whereas H0, not strong evidence, or weak. How about I say weak evidence? Weak evidence. Does that make sense? So know that. HO is concluded when things are weak, like you assume innocence, automatically, unless evidence is strong for H1. Okay, so having those three facts, let's go back. So what happened in this problem? The P was not low, wasn't low enough, the evidence wasn't strong enough, so the null did not go. We kept the null. We kept the original assumption, like innocence, right? Evidence was weak in this case, right? Evidence was weak. Remember, that's what I said. Whenever you're going with the null, right? See what I'm saying here? Evidence is weak whenever you're going with the null. You tracking with me? So the evidence is weak. We stick with 0.52, but we're not like sure it's equal to 0.52. Like, I'm not sure of that young man's innocence, but I'm not sure of his guilt, so we let him go. Right? Does that make sense? So which of these is right? There is not sufficient evidence. Yeah, it's going to be one of those not sufficient evidence because we went with the null. Whenever you go with the null, that means there was not strong evidence. Maybe I should write it that way. Not sufficient. Not sufficient evidence or weak evidence. Same thing. Not enough evidence. How about that? Is that better? Not sufficient evidence. The DA, in my case, did not supply strong enough evidence. I'm sure she was angry with us, but I don't think she had strong enough evidence. There's too many people unsure about too much stuff. So, not sufficient evidence. So, yeah, whenever you go with the null, you're sticking with what was assumed in the beginning because there was not strong enough evidence. So which one is it? There's two of those. Not sufficient evidence. Is that the only one? To support the claim that the percentage adults would erase all their, if they could, is more than, there's not sufficient to support the claim. Right, yeah, that's it. There's not sufficient evidence to support the claim. Are we good there? Is this making a little bit of sense? How are we doing? You guys tired of this stuff? All right. How many? Let's keep going. Okay, so here we go. We're on number 9. Assume a significance level 0.01. So now they're wanting even stronger evidence. Whatever. Same thing. Original claim. Standard deviation of pulse rates of a certain group of adult males is more than 16. Hypothesis test results are 0.3555. Try to answer the questions. All right. Can you do that one rather than me just whip it out? Think you'll get more out? Even though they don't make us, I think it'll help you to write the null and write the, we'll start with the claim, right? I forgot about that. Always start with the claim. So can you write the claim on this one? Try that. So try writing the claim and then put it either in H0 or in H1. Remember, H0 is always the equals one. What's the claim? Oh, standard deviation. Oh, that's the sigma thing. Remember that? That's the sigma. Anyway, whatever. You can just put S. It doesn't matter. Sigma is what? More than 16. We good? If you just did S, sure, whatever letter, doesn't matter. Main thing is you got the greater than 16. We good there? That's the claim greater than 16. Okay, so now, I'm just going for the words there, right? More than 16, greater than 16. So, does that go in the HO or the H1? Yeah, because the HO is always the equals, huh? Always. There's no S on there. Always the equals, right? So that's not the HO. Right? If you go back here, HO is always the equals. So that must be the H1. You tracking with me? And this must be equals. The HO is always equals, right? Okay? Now, what did the next what the p-value tells you the results of the test? What did the p-value come out to be? 0.3555. Is that a low one or not? Not low. Not low enough. In fact, they're wanting it even under 0.01. They wanted it even lower. They wanted really strong results. So it's not low enough, is it? It's not low enough. So what does that mean then when it's not so low? HO will not go away. Right? You tracking with me? HO will not go away. If the P is low, the null must go, but the P is not low, so the null's not going to go away. So we're going to keep the null, aren't we? We're going to keep it, meaning we're going to keep our original assumption. Evidence was just not strong enough. There's a 35% chance, or 36 or whatever, that it's just luck. There's a chance. There's just too big of a chance that the data we collected is just lucky. It doesn't really mean that's really the truth. It's just too much of a chance of luck. It's not strong evidence. So we're keeping the null. So reject the null? No. We're not rejecting the null. We're failing to reject the null. Why? Because the p-value is less than? No, because the p-value is greater, huh? See, is that making more sense now? Is that good? We failed to reject the null because the p-value is greater than alpha. Part B. Without using technical terms, what does that mean? Well, we're keeping this result, aren't we? Now, does that mean, now we look at this third part that I wrote. We assume not sufficient evidence or strong evidence. Yeah, whenever you keep HO, you're saying there was not sufficient evidence to move you off of that assumption. So we're looking for not sufficient evidence. So there is sufficient? No way. There is not sufficient? Yeah. To support the claim that's more than 16. Yeah, there it is. Not sufficient evidence. Whenever you end up going with HO, which we did, right? We ended up sticking with HO because the P was not low, so the null did not go. We stayed with the null. That always means there was not sufficient evidence. There was too much of a chance of luck. 35% chance of luck. Is that good? Getting more comfortable? Questions on that one? Type 1 and type 2 errors. Now, there's two mistakes that can be made. A type 1 error is the mistake of rejecting the null when it is actually true. Alpha is used to represent the probability of a type 1 error. Rejecting the null when it's actually true. Right? Or type 2, failing to reject the null when it's actually false. So basically, you got a guilty person and you failed to bring down a guilty verdict. Or you got an innocent person and you lock them up. Right? Two mistakes that can happen in a court of law. Right? The innocent can be called guilty or the guilty can be called innocent. So that's what the type 1, type 2 errors are. So type 1 is rejecting the null when it's actually true. Rejecting the null. So type 1, rejecting the null when it's actually true. So I'll write this out in a minute for you. So, and then, yeah, that table could be helpful at different times. I don't think we need it right now. Describing type 1, type 2 error. Yeah, let's just go to our examples. We're running out of time. So I'm going to go to my example. Type 1 error. Reject the null when it was true. And then type 2 error. What did they say type 2 was? I want to use their words. Type 2 is failing to reject the null when it's false. Okay. Failing to reject the null. Failing to reject the null when it was false, and so you should have rejected it. All right, so there's the two types of errors you can make. The chance, the probability of a type 1 error is alpha. That's a Greek A, alpha, which is called the significance level, which is normally 0.05. So that alpha, that significance level, that's exactly what you're setting when you pick a significance level. You're setting the probability of rejecting the null when it was actually true. You're saying we need evidence beyond a 5% chance of luck. Okay, so let's look at an example. This is something that's weird. It'll take a little bit of time to get used to, I think. And we've got 5 minutes. Okay. All right, we got that copied down. Let's take a look. Okay, identify the type 1, type 2 errors that correspond to the given hypothesis. The proportion of people who write with their left hand is equal to 0.16. Okay, here we go. What's the claim? So this is a claim. 0.16, huh? That's the claim. Okay. What? I'm sorry, I shouldn't write HO. Why did I do that? P. The proportion equals 0.16. Okay, so now let's do HO, H1. Is that HO or is that H1? How do we know it's HO? Always equal. Good job. You're getting the hang of this. And so now what's the opposite of equals?
Not equal.
Not equals. Yeah, you put not equals there. Everybody see why we do that? When HO is equals, the opposite of that is not equals. Okay, now what would a type 1 error be? Let's go back and look. Type 1 error, rejecting the null when it's true. So you would take this null and you would reject it, but it was actually true. You reject the null when it's actually true, which means the population actually was 0.16, and you said, no, it's not 0.16. You tracking with me? The null was true, but you rejected it. So let's see. Reject the claim that the proportion who write with their left hand is when the proportion is actually. You reject the claim that the proportion who write with their left hand is when the proportion actually is. Yep. There it is. You reject the claim that it's 0.16 when it actually is, right? You reject the 0.16 claim. No? That's what that would be. Now, what's a type 2 error? So that's fail to reject the null when it, in reality, is false and thus should have been rejected. Right? So same HO, same H1. Okay, so what is it saying we do? We fail to reject. So we keep it. But it's really false. We made an error. The jury made an error. Right? We're saying we kept it. We failed to reject it. So we kept it. But it's really false. So it's really false. So what does that mean? Failed to, yeah, it's one of the failed to rejects, right? It's one of the failed to reject. Failed to reject the claim. Is that the claim? Is this the claim? Yes. Equals. That is the claim. So failed to reject the claim that the proportion right of the left hand is 0.16 when the proportion is actually different. Yeah, this is false. It's actually different. Yeah, that's it exactly. Is that making some sense? Let's look at one more. We got 2 minutes. Okay. Type 1, type 2. Here we go. Start with the claim. Here's the claim. Yeah. Percentage is less than 35%. College students who own cars. So the claim is P is less than 0.35, right? Less than 0.35. All right. So is that HO or H1? Yeah, it's H1. Excuse me. How do we know that's H1? Yeah, it's not equals, huh? So that's the H1, and the HO is the equals. Good. And I'm going to write claim next to this one because that one is the claim, isn't it? All right. So what's a type 1 error? Go back here. Type 1 is reject HO when it's true. So type 1 is reject HO when it is true. So I rejected that, but it's actually true. I rejected that when it's actually true. So failed to reject? No, we did reject. Reject the null, reject. It's either B or C, huh? Because we rejected the null. That the percentage of college students own cars is equal to 0.35. When that percentage is actually, yeah, B, huh? That's actually the deal. It's actually true. Is that making sense? Type 1 and then type 2 is the other way. I'm sure you can get that.